So for our project, Julie and I did, we researched alternative energy, which is any kind of energy that is renewable and doesn't use conventional fossil fuels. So over time, more and more methods of alternative energy have developed, which helps decrease the amount of pollution and greenhouse gases which unfortunately contribute to global warming and climate change. Um, but unfortunately, fossil fuels, since they're so much less expensive, are still used most. So our project, we explored current alternative energy methods that are being developed. Specifically, we focused on solar energy, such as the artificial leaf or bionic leaf, and solar panels, along with the discovery of a new catalyst.
So, first, we'll be talking about why solar panels and solar energy is one of the most promising forms of alternative energy. Currently, it only makes up about 2% of energy consumption in the United States, as seen in the figure on the left, but it is thought to be promising because of its low maintenance costs. Since solar panels aren't very expensive once they're installed, it will lead to people saving money on electricity bills, which would make them more appealing in the long run. Next, we'll be talking about the chemistry in solar panels.
So this is the type of cell that solar panels use, a photovoltaic cell. It works by capturing energy from the sun's radiation in the form of photons. Then, once the absorbed photons, dislodge electrons from the semiconductor in the cell. In this case, if you look in this picture, the semiconductor would be the silicone on the bottom there. And then at this point, there's oppositely charged poles. So you have the positive silicone and the negative electrons, which induces an electric current, and the electrons flow.
So, as mentioned in the previous slide, solar panels are made up of photovoltaic cells. And so, during the daytime, when sunlight hits a solar panel, the excess energy that was not being used in the photovoltaic cell is used to split water into hydrogen and oxygen. Then at night, the hydrogen and oxygen are recombined in a fuel cell to continue to produce energy. Normally, solar energy is hard to store, but the new oxygen-generating catalyst found by professors at MIT allows for water to be split easily and is very inexpensive. So, fuel cells convert chemical energy into electrical energy through redox reactions, and that is what is used in the solar panels from the previous slide. So hydrogen is passed through the anode and oxygen is passed through the cathode, and when the electrons are stripped at the cathode site, they are passed through a circuit and create electricity when reacted with protons and oxygen from the air. The only byproduct of a fuel cell is water, which makes them a very clean source of energy. A real-life example of this is in Italy, where a pasta factory has been using fuel cells to produce pasta. The picture on the top right is of a gas compressor, where the bottom is the hydrogen tanks, and the owner of the pasta factory has recommended using fuel cells because it's much better for the environment and in the long run will be much more efficient.
So this is the artificial leaf that was mentioned earlier. It's made up of a living and non-living part. So in the non-living part, there is a wafer, which uses a light-driven reaction and produces hydrogen gas from water. Specifically, it does this by water splitting. The living part of the leaf is made up of a genetically engineered bacterial strain, which uses the hydrogen gas that was produced in the non-living part to make isopropanol, which would be the fuel. However, a difficulty of using this leaf is that you really need to optimize all of the parameters. So this means you need the maximum voltage point of the cell to match the potential for water splitting, so you have enough energy in the cell. And you also need the exact right catalyst. So it needs to obviously be able to effectively lower the operating potential of water splitting, which means that the best option for this is a transition metal or their oxides. And also it needs to be able to operate at a neutral pH so that it's stable and the device remains sealed. And then, although it's similar to a solar panel, it is different because normal solar panels are converting sunlight into electricity, which is then stored in batteries. But the leaf is essentially performing photosynthesis by converting carbon dioxide from the environment into usable fuel.
So, an experiment done in the Netherlands determined the efficiency of photoelectrochemical water splitting by measuring the solar to hydrogen conversion of different catalysts at different densities. And that's how they determined the best catalyst to be used. So, the catalysts that they used were ruthenium oxide and cobalt oxide, which are both earth abundant catalysts, as shown by the graph. And as shown by the graph, the oxygen evolution was more efficient since there was larger produced voltage than the hydrogen evolution, which shows that this catalyst was best for splitting oxygen.
So some of the difficulties of solar panels include their high costs, unattractive appearances, and the fact that their production produces hazardous silicon waste. Other disadvantages of the solar panels is that they need access to the sun for 60% of the time. They need an energy backup system, and they need an energy storage system, and they likely need an energy backup system depending on how much energy you're using that you're collecting. The most unappealing factor of solar panels is likely that it takes 40 to 50 years for any energy savings to make up for the initial cost to install them and purchase them. Additionally, since they're made out of rare earth metals that can be toxic, the process to recycle them is difficult, and often they end up just as waste when they're too old for reuse. And then as far as advantages, solar panels have many advantages when compared to other forms of energy. Some examples include that the sunlight it requires is totally free, they're quiet, and they do not disturb land much or bring any pollution. Additionally, the installation of solar panels is quick and very easy to add more later. And as photovoltaic cells, they're able to last for decades.
So, some of the main goals relating to solar energy usage in the future include increasing efficiency and reducing cost. If solar panels were able to convert a greater percentage of the sunlight that they captured into energy, they would likely be more appealing to consumers. Besides making them more efficient, by using thinner solar cells would make them less expensive. And if these improvements are made, it is predicted that the amount of solar power produced in the United States will increase by 700% by about 2050. And if more solar energy is used, it will also, as mentioned in the introduction, help with climate change and global warming.